cost estimations. So there are lot more which is going to come in the underground sector, which is upcoming industry for civil. And why tunnel? So all you may be knowing that why we are going to go in underground. Like basically there are issue with the land acquisition. There are a lot of traffic congestions in all the urban areas, and there are shorter alignment network which we can able to connect through the underground, and it can reduce the pollutions and some maintenance also we can plan accordingly, because in elevated there are a lot of issues which we can uh, able to maintain that. And obviously the demolition of the structures takes a lot of time, and the land acquisition issues are there, and there are legal proceedings which is still ongoing to get the land acquisition. So in order to avoid all those things, and also the utilities which are coming, there are water pipelines and there are channels, so which is coming on the surface, which we may not be able to avoid and divert those things. During that case, we plan to go for an underground tunnel network in urban areas. So just to have that, there are different types of tunneling where we have the tunneling like mechanical way, and there are conventional way of tunneling. So if you consider the mechanical way of tunneling, there are tunnel boring machines which is been there in India from the past 20 years right now. So from starting from Delhi Metro, there are a lot of TVMs which is been working in the urban network right now. So these TVMs bore through a variety of ground conditions with soft ground to hard rocks, and there are mixed ground conditions. And this is being equipped with the state of art navigation systems, which is being there with the TVM. So we can take one more session because TVM, there are a lot of types are there. One is the hard rock TVM, and another is EPB, arc pressure balance TVMs, and there is a slurry TVMs. So there are different types of TVMs available in the market based on the geology and based on the requirements. We go for a selection of the TBM. So even there was a paper which I have worked with LNT and published for the Mumbai geology, that how to select the TBM. So it is available freely in the online. So you can just go through that paper to know that how we are going to select the TBM for a specific geological conditions. So basically in Himalayan tunneling, and there we go for an hard rock TVMs, and even if when we are getting a full phase rock here with a good grade rock, we'll go for hard rock TVMs. But generally in mixed geologicals, either we go for slurry TVM or EPB TVM in urban tunnels. So just to show, because since you may be not knowing about the services within the metro, so there are a lot of around 17 interface contractors will be working in metro, and all the services we need to equip within the tunnel. So there are different types of services like OHE, and there are the tunnel ventilation systems, there are signaling, and there are cabling, and there is a walkway, and the traction people will be coming, and there is a rolling stock. So there are a lot of services like this which is going to come within the tunnel. About this is about tunnel which is done through the TBM, and this is the arrangement of the universal ring with a 5 plus 1 key, which is precast segments. This is how the arrangement looks in the segments, and this is the casting yard, how they are going to produce the segments, the precast segments, and how they are going to stacking there. And there are several checks which we perform during the segment lining, where we check even the vacuum lifting, stacking, and handling and erector, and even the TVM torque, which is going to give the maximum thrust. So that also we need to check. And considering the ground conditions, what is the maximum and minimum ore burden, which need to be taken care. And the hydrological and geological conditions across the alignment also need to be studied there. So this is just about roughly about the TBM tunneling, which I just wanted to give a small glimpse. So probably one more session which would cover in detail depth about the TBM tunneling, and there are a lot of challenges also we faced in different geological conditions, where we got some surprises that one of the zones we got a garbage at around 40-50 feet depth. So, and we had to stop the TBN,
I'm
and
sorry
we
to
are going
interrupt.
to.
I think your screen is not moving. The slides are not moving. It's
Yeah,
stuck on the first page.
on my sorry. Is it moving now?
Yeah, yeah, yeah.
Is it working now?
Yes, sir.
Okay, sorry then. I just
Pratap,
go through the.
sorry, shoot not. So if you can put it in full screen mode, that will be also be better. I'm feeling.
Okay, let me see. I'll just reshare the screen and see.
Yeah.
Is it visible now?
Still not in full screen mode.
On just take. You mean entire screen sharing, right?
Yeah, I mean that PPT will be like entire the PPT if you can put rather than putting the side layout. Without side layout, if you can keep it in full screen mode, means that will be.
Now?
Yeah, this is better for us.
Okay. Sorry, I think some of the slides you might be missing. I'll just show that what are the slides which were shown in the earlier. So sorry to that. Uh, These were the slides which were I was explaining about the tunneling, why the tunnel is necessary, and how the TBM things which are going to be taken for the consideration of the geological conditions. And these are the types of TBM which I was briefing in just few minutes back about the types of TBM which we are going to select in this one. And these were the services which I was showing. Probably this was the sketch which I wanted to show that so many services being involved in the typical cross sections where many of the interface peoples are going to come and put their services, and we need to accommodate the space for them, and also the loading stack, which is the train has to move, and even traction, everything has to be kept. In few of the projects, there is a third rail arrangement, not overhead arrangement for the power supply. So there are different services which is going to come, and this was the segment arrangement which I was telling about. It was a 5+1 key arrangement which is there, and this is the photos which shows about the segment casting and stacking at a casting yard, how they are going to cast these segments which is precast and which will be supplied to TBM for the erection of the segments. And these were the checks which we are trying to perform, where we even check with the vacuum lifting with the initial strength of the segment, and even stacking also we need to check with the cantilever, and then the handling with the erection also need to be checked, and mainly the TBM thrust force, because the different dia TBMs are available in the market and different torque and thrust will be producing, and that test need to be checked with the segment whether it will take or not, and mainly the minimum overburden and maximum overburden within the geological conditions in the alignment we need to check, and with the hydrological and geological conditions also we need to have a check. So this is about the normal precast tunneling, which is done through the mechanical way, which is mechanized tunnels with the tunnel boring machines. So this is how the finished TBMs looks with the services after the completion. So this is just to make a small glimpse of the presentation, just to show that TBM network is one of the booming right now, because there are a lot of tunnel boring machines working in urban areas, and all the major cities are having connectivity with this. So just move on to the new string tunneling method, which was kept for today's session. So I'll be covering most of the NATM aspects which is being taken in construction as well as the design. So how the sequences are going and how the monitoring aspects which we are going to cover within this. So just to say that what is an atom, because people try to see that generally they think that okay, there is an excavation going on. How what is an atom? It is an excavation considered as a load-bearing structure with an stress-bearing rock mass arch. So we are trying to create an arch for the excavation. That excavation is done through a manually, and this atom is completely based on the observation approach, because we follow the preliminary design and then the construction. So it has to match completely with an observation approach. So then the people generally in Austria, these they call it as like they won't call as a conventional tunnel, but in India there is a misinterpretation that there is a conventional tunnel is also same as NATM, because conventional tunnel describes only about the construction aspects and the process which is being taken in the thing, but where NATM covers complete design and the execution and even the observational approach during the construction. So that's how the terms which is defined there. And only by putting a short shortcut and rock bolts is not alone an atom. And just to have like what are the objective to take the design support, because we just need to see whether the settlements are an issue, where is a soft ground there. So deep tunnel, no. But if it is a shallow tunnel, definitely it is a issue with the settlement, and we need to make a system totally support with a short-term goal about the excavation, and to before the lining, we need to put some additional supports there. And if we look at the cross section, the strength of the ground allow opening the same in one go. That we have to decide based on the construction logistics and based on the excavation geological area there, whether we can go with a full phase excavation or what. So that we in the next slides I'll just show that what are the types of like partition excavations which we can plan there. And if the rock mass shows squeezing, like few areas where we find the squeezing ground conditions also there. So whether support can be designed to take a short-term displacement. If yes, then it has to be taken. Some measures has to be taken in order to take the additional support and integrity of the structures. So that is very much important in atom. Just to see that like different kind of ground conditions and different kind of support systems which we need to plan. So one is the like different types of partial excavations we pre-plan. If the ground condition supports very well and the ground rock mass is very good within higher UCS values and with a grade 1 or grade 2 kind of rock which is available and very less joints are there, then definitely we go for a full face excavation, which that depends on the shape also and depends on the volume of excavation which we are going to do with the logistic support. So if there is a very small cross passage kind of excavation, we can go full face with a good rock conditions. Similarly, for excavation 2, which we call it as like support class 1 and 2 is for good rocks, and support class 3 is for a better rock, which is fair rock, which is grade 3, which comes with like some small basaltic and some granitic rock marks with have slight giants also there with that. So this is also again there is no issue with the stability as such, but the support system which should be robust. That we need to check and plan accordingly. And third one is about the class 4, which is almost a poor rock conditions where can be a condition like a squeezing rock with the high support density. And we need to see that how much partition we have to do in the excavation. Generally, we go for a heading and benching. Like top, we call it as heading, and the bottom portion of the excavation we call it as benching. So that we have to plan accordingly for the class support class 4. The support class 5 is a very poor rock. It's a mix of weathering conditions with a very poor rock mass where we need to look at the stability of the uh, uh, excavation, where we may need a higher supports and higher uh, rock poles or 4 poles, and that additional measures need to be taken. The atom is possible in soil also, but where we plan for a sector excavations, where we go for very weak zones and divided into multiple portions of the excavation, and we stabilize one sector every time and go ahead for the next sectors. So this is support class 5 we call. So, like, if any of the critical sections which we need to plan in the some of the special cross sections which is there, and the client is requiring something like this, then how we are going to develop? In phase 1, we go for a small heading and we complete an atom in phase 2 with a one section. Then we start developing the other section because all this support installation will take place after the excavation. Then phase 3 we extend it, and phase 4 again we further move on to the sector excavations on either side, and then the central part will be taken out. Then the complete section which we are planning has to be taken care. And all these stages need to be followed very carefully. All the support installations and temporary, whatever the shortcut or four pole or whatever the rock poles support system is there, that need to be kept in place. So also because this is a drill and blast, and in any of the good geological conditions where the rock grade is high and we need to plan for blasting. So this is how first they drill the pattern. First they design the pattern, how they are charging and everything. Then they drill, they charge and they blast. Then all the excavated material will be loaded. They'll scale it and clean, and the bolting and supporting system will take place. So this is the activity chart in the NATM. Generally, like what is the major share, like how much percentage which we can divide. So this is how it looks like: drilling the holes for blasting and high explosives. Then need to plan for ventilation, scaling, mucking, and geological documentation, like installation of steel ribs or lattice girders and wire mesh shortcuts. So this is how the activity charts divide for an atom working stages. So just to say that we were discussing about the partial excavations where support class can be divided accordingly. So this is how the full phase excavation where a complete excavation can be taken in one go, and this is how the top bench and invert excavation will be taking place. I'll show a few photographs of the site also, how that excavation will be taken care. So this is heading and this is benching. And this is partial excavation with side galleries. As we planned that with the partial excavations, we divided in different sectors and started excavation. And partial excavation, this is one side gallery only. So this is an excavation where the top heading and benching which is being followed. And this is the sector excavations where they're planning blocks of because which is a poor condition of soil, so they are taking in the sector excavations there. And this is the side gallery excavation, which is being planned outside. So as you maybe like lot of caverns, underground caverns also coming in India in most of this storage in most of the sea zones, they are planning these caverns. So caverns requires a different kind of study and lot of construction sequence need to be planned. And this is how the sequencing which we plan and the excavation blocks we can plan here. So this is one of the typical cavern, how this excavation will be planned for the cavern. So blasting generally it's a conventional explosives and sludgy explosives and detonating rock arts. So different detonators are there with the electric and non-electric. So there is an agency which we designed the underground blast design specifically with a lesser disturbance, and even there is a limits for the vibrations in the urban area. So that need to be planned, and these detonators has to kept in every time interval with a half a second or milliseconds. So that they will plan, and we will once the charge, then we blast it and take out the material later on. So this is one of the charging they are trying to do after drilling the hole and doing the charging, and then the excavation is being taking place after the blast. So after the blast, the loading and mucking has to be planned. So this is one of the excavators which is being taken, and the materials being taken out, and the dump truck being filled, and they're taking out from the tunnel. So the next is the support sequences, where the major thing is about the scaling and shortcut sealing, whether it is required, wire mesh, and then steel ribs or lattice girders, which is requirement, and shortcutting and bolting. So because after the excavation, there you have to see that whether the face is undulating or it is not flat enough, and there are a lot of over excavation may be done during the breakers or anything. Then we may require some face sealing shortcut, which we can cover with that. Then we may need the wire mesh need to be put. So what is the use of function of the wire mesh is about the stabilization of applied shortcut until the setting and hardening take place, and it gives a initial shear strength which it can increase in the shear strength of the ground, and it can also act as a reinforcement to the joints. It will reduce the limitation of shortcut cracking due to creep and O stressing, and also preventing dropping of shortcut portion after cracking or failing of the line. So generally we go for 150, 150 with a 6 wire mesh, these things. So with the proper fixing of the shortcut, this is how it looks. But if you don't fix properly, then again you're not supporting the joints, or not properly keeping the rock mass above there. Based on the conditions, we go for one layer thickness of the shortcut. We go for one layer or two layer wire mesh. So this is how they install the wire mesh at site. They'll because always one overlapping is to be required with the other or overlapping for the wire mesh. So next is steel ribs, where we are having some soft ground or support class 2, like support class 3, 4, like weak ground conditions are there. We may go for additional support, such as steel ribs or some lattice girders. So the function of this is to have a load distribution. It's basically an arching effect which we are taking from the top and distributing the load to these temporary supports which we are doing, and we will try to maintain the profile of the atom the same. And it also supports the four poles, like in weak ground conditions we may go for additional four poling. That also I'll show in the next slides. So this is how these steel ribs been uh, kept, and this is the lattice girders. So this is the installation of steel ribs on of the sides, and this is how the setting of the lattice girders also been shown as a primary support. Yeah, and after these, it is to be like shortcut is one of the major aspects in the atom. So it to avoid first loosening of the surrounding ground, that is the sealing shortcut, and it closes the joints and prevents fall downs. And this is a like first layer will be the sealing shortcut, then the main shortcut will be coming, because after the wire mesh or steel ribs or whatever lattice girders, that entire thickness need to be covered with a shortcut. So the components of shortcut is cement, aggregates, additives, water, admixtures. So based on the type of ground conditions, it can be planned. So there is a mixed design which we try to check with that, and the grading of curves with the aggregates and type of accelerator, and we need to get the 28 day strength, and early strength development, generally we call J2 curve, need to be satisfied for the mixed designs. So this is how the shortcut selection will be taken place at site. So there are a lot of shortcut methods. It is dry method, wet method, and semi-wet methods. There are a lot of equipments also there, which covers the shortcut installation. So there is machineries all there now. There is an advanced technology, and lot of machines have come. Ease of construction is there to do the shortcutting earlier, because earlier they were used to do the manual shortcutting by hand, but now there is a lot of robojets have come and do the shortcutting. So after this shortcut, and we the primary focus about the like stitching of the joints and additional support system need to be required with the rock bolting, and the wedges are going to form above this atom. So those wedges need to be stitched with the rock bolts. So this is a main supporting element apart from the surrounding rock itself, and it can improve the rock quality by increasing the shear strength. So there are like if pre-stress is there, then quasi-dimensional stress conditions will be applying with the confining pressure, and it will reduce the displacement of the lining even if there is a stress which is acting behind the lining. So that will reduce with this. And depending on the fracturing, cleavage, folding, buckling, shear failure of the rock, the rock bolts will prevent entire failure of the rock close of the tunnel. With rock bolts broken, rock still remains the capable of providing the support. So as you can see that this is the radial direction in the longitudinal direction. This is how the direction of rock bolts, like plus or minus 10-degree inclination, we will try to plan. So in this rock bolt, different types are there. SN bolts, which is there with the systematic bolting, and there is a self-drilling bolts, and there is injection bolting. All these bolts are like once they will drill the hole, do the bolt they'll keep and they'll grout it. That's how the system works. and there are not grouted bolts. So generally use it for swell X and expansion bolting. This generally depends on the mapping. After the mapping, they go for a spot bolting whether an additional support requirement is there, and immediately they want to, like the rock is started moving, they want to do as some immediate bolting. So these kind of bolting arrangement they'll plan at site. For polling, this is also one of the important thing in soft ground conditions. It is being used in most of the NATMs across India. So these four polling are support measures installed in the tunnel directions prior to the excavations. They shorten the free span of the unsupported excavation surface, and these four pole supports will aid in excavation and will have less function after the installation of initial supports. As you can see here, like without four pole, if I start excavation, this is the span which I was trying to excavate. If I excavate without any four pole, there is a chances of getting an over excavation, or the excavation there could be a failure which is at, from the top. So that could be a chances if whether it is in the soft grounds. Like if I install the four poles, the excavation will be very smooth, and each round I can complete it very, and even my theoretical excavation and the practical excavation is almost matching. And also these four poles, if not grouted, how the loosening of soil may take place at the top, and if it is grouted, it is much robust. Yeah. So this is how the excavation for with the four poling takes place, and this is how the four poles been installed. So like as I said, the lattice girder or steel ribs also will take a support of the four poles. So this is the four poles. This is pipe proof. In like poor geological conditions where we may have to support and complete at the top for having any arching failure or anything. So we go for an pipe proof conditions where this pipe will be filled with grout completely. So that's how this works. In difficult ground conditions, there are a lot of additional elements in NATM where we need to split the support system also. Like at the heading itself, we go for some elephant footing so that the stability of the system should be there. And this pipe proofing also we will plan with a different dia of the grouting pipes. And the lining stress controls also will be kept, and staged excavations we will plan like based on the conditions of the ground. We limit the volume of excavation to a certain distance that it should be safe enough to go ahead, like by splitting into a side galleries, and especially staged excavations we plan accordingly. So adequate support to prevent loosening from very beginning. So that's the main motto, that we need to give an adequate support for each sector which we are excavating on this. And about this NATM, this is one of the important thing because the observational method which we are planning, that is very much important. First, we need to predict, measures and design optimization, and then monitor. So this prediction, monitoring, measure and design optimization will take place because the monitoring of the ground conditions is very key aspects of the NATM. Yeah. So there are different kind of geomechanical and physical dimensions. So length, changes in the length and dimensions, and if they are done a over excavation or ground is moving or wedges are forming. So this is we need to see because in design stage we go for an investigation and in situ test for determination of the ground behavior. But in the construction stage, the monitoring of ground conditions with the behavior at different stages need to be checked, and it need to be verified with the geological models which we have already estimated initially, and you need to be reiterated with the ground conditions actually we are getting from the stage. And in operation stage, we need to see that the stability is controlled with the critical monitoring, and long-term monitoring also need to be planned if after the completion of everything, whether the ground is stable or there is no further values. So there are different monitoring instruments also there now. So there are rock bolts which we are monitoring with the measuring anchors, and the extension meters are there to check the stress movement within the soil. And there are strain meters being installed across the profile of the NATM. And there are pressure cells which we taken control of the pressure values which we are getting in the NATM. So there are other instruments. There are optical 3D targets also there, which we take the three dimension XYZ directions values about the movement, if any. So there are monitoring. So there would be probably another session required just for the monitoring of the atom itself. So just to see that after this primary support being done, all this temporary works is done for the atom. So there is an aspect for the permanent line where we keep the system stable and do the permanent lining. So why the permanent lining? It needs to be waterproof, and the load transfer between primary lining and final lining should be there, and additional factor of safety from the structural point of view is required, and any installation of equipments and everything is need to be planned within this. And there are different types of permanent lining in the atom. Now there is a cast in situ most commonly, which is being widely used in the worldwide, and nowadays they are going with a shotcrete as a permanent lining with steel uh, mix, like some uh, mixing also is like nowadays studies is also going with the shotcrete that they just want to spray it and uh, do that as a permanent line. So this is how the cast in situ permanent shell lining will be there. First, we'll have a ground condition. After excavation, we'll have a shotcrete lining here. Then we have a waterproofing sheet membrane, then the permanent secondary lining, which is coming here. So this we call it as primary support. This we call it as secondary support for the atom. And say about the composite shell lining, where we have same conditions. First we have shotcrete, but instead of sheet membrane, they are going with a sprayed membrane here. Then the permanent secondary lining will be there. So this is how the waterproofing for the cast in situ permanent lining will be done. Uh, and this is the shuttering which is being taken within the cast in situ, and they do the final lining of the atom. And this is a sprayed concrete permanent lining. They do after the installation of the reinforcement. They'll just spray this, and there's even admixtures also come. Steel mix also they are doing now. So just to take into cover about the design aspects, because all these design aspect covers about the primary support and the final lining. So this is depends on the observational approach from the site, and it shall be based on the accepted analytical and finality analysis which we need to plan. And this is the following chart which we can depict about the designs. Like first we go see the geological models, and the material parameters we will select, and we will see that what are the geological units, what kind of grading is there, at what depth we are there. So those things we plan, and overall construction sequence need to be planned, because how much volume need to be taken out, and what is the time period, and what is the timeline. So these things will be planned at initially, and with that construction sequence is done with the ground conditions. We plan whether analytical or empirical numerical calculations will be done based on that. And with that evaluation of results, if the results are getting okay, then we go for a definition of mine support elements with the construction sequence. And if any special requirements like an ground improvement prior to the excavation, or if any additional support requirement are there for the mine support, that we will plan. And this pre-dimensioning also will done. And again, the same operation. Again, after this, all the design is done. Once the site start the excavation, the observation approach will start during the construction. If any additional support requirement or redesign of the things is required, that is very much important. So this is about the safety and long-term stability and the environmental requirements which we need to plan in the geotechnical designs. So, like step one is about the determination of ground types and determination of ground behavior with the assigned ground types. Like in determination of the ground types, there are a lot of categories which are there, like considering the stable ground conditions, potentially discontinued rock block fall, and there's shallow fire conditions. This voluminous stress induced failures, rock burst, buckling, ground failure, traveling ground, flowing ground, swelling ground, ground with frequency changing deformation characteristics. So these are different types of behavior types of the ground. So which we need to check with the determination of the ground types. Then the same the flow chart which we are trying to keep, the things will follow. and we need to plan with the refinement of the ground model for short-term prediction and excavation section, and the comparison with the framework plan, and determination of excavation and support, and refined prediction of system behavior in support sections. So this is how after these conditions works, because basically this we divide into two zones where we tell that the determination of excavation and support all these, and the later on the system behavior. So we need to check all these supports are adequate with the system behavior, and if everything is okay, then we go for an approval for the final line. So this is the numerical analysis. It's a very small section where we done some cross passage, but there are a lot of bigger sections. I'll show the pictures of the site and the sequence which we followed with the critical challenges which we face. So in normal finite element model, we just try to do, and with the different type of ground conditions, we keep the layers with respect to the data which is available with the geotechnical interpretive report. And this is how the model stages works with the grid setup, and we'll keep this initial stress field and activate the surcharge, and again the excavation of heading and relaxation of the internal pressure, because this relaxation will consider in order to get a conservative results there. And green shortcut, the application of the shortcut will activate, and again we relax the ground with an 80%. It's just for a small portion. We are trying to get more conservative way of results, so that's why we are trying to relax the ground there. And excavation of further relaxation and bench invert excavation, and the shortcut will be activated at the next step. After that, the bench also, and about the completion of the closure of the ring. So this is how the axial force diagram after the RS2 analysis, and this is the bending moment diagram, and this is the lining displacement, and this is the vertical settlement, the tunnel. After these results, by taking the axial force and bending moment, we take the P by M, the structural capacity as per IS 456. We need to check all these plots are within the limit zone. So as I was, this is about the design aspects of the tunnel. So there are empirical approaches and analytical approaches by Feder and other people are there. So the same similar way, they'll also calculate the lining forces and the bending moment. And different checks needs to be done for four pole, which is again empirical. So all these support system also need to be checked with the empirical calculations. So just I was quoting about the critical challenging project which was in Mumbai, which is the first crossover being built in the underground, that too in the urban area. So this is how the arrangement looks, because if you see, these are the TBM board tunnels, either side, and we are creating a crossover between these board tunnel with a different NATM sizes like A, B, C, D, E, F. These are the sizes which we plan. Almost 6 types of the sizes we kept, and all these sizes having different, and this movement is taper. So this is one of the critical aspects of the project. So this is how the section works, because if you see the size of the NATM, it's quite big. The bigger one is the 16 meters width and 10-meter height. So this is a bigger section, which is F section. So with a thickness of 450 permanent lining and chart with thickness of 300. So that's how we plan. Like the sequence, if we want to brief, like this was the tunnel which is being done, and they did the breakthrough in the station. And since the other tunnel is coming very slow, so we need to, because timelines were very tight, because we need to complete the excavation and create this crossover. So what we did, we started excavating the NATM portion by breaking the segments here. Like this was the portion we started excavating on this tunnel after the breakthrough by breaking the segments. And then we went this third portion, and we went for the fourth NATM small section there. So after this, the TVM was almost crossing this area, and we just started breaking the segments on stage 5. By the time the breakthrough took place for the other tunnel. So this board tunnel is also clear now. So now we have an access to this area to do the excavations. So we took the other tunnel with a connection. This is 7, and we created a connectivity in order to have the logistics movement and the excavation of the muck within this cross connections. And unfinished, finally, we connected the central portion which was there, and either end of the small sections, we finished at the stage 10. So these are the what real photographs at that. This is the Sahar station where this TBM breakthrough took place. This was the one tunnel which is already finished. This was the other tunnel which was about to come. So by that time we already started excavating within this tunnel. So how we, and also one of the crucial challenges was above this there were hutments and there is no space available at the surface in order to do any improvement of the ground or anything. And even there is even a small bike also cannot go within these streets. That kind of this one there. And in fact, we were observing the ground and for any movements, and we infected. These are dilapidated buildings also, and where of the some of the buildings we kept some monitoring and building settlement markers, everything in place. So this is how we started breaking the segments. First, we started breaking the precast segments here, and pre-supports also installed. And after breaking, we tried to create a one round, a full phase there. And after that, we started developing the complete section with installation of 4 poles and wire mesh. So this is how the finished section. This is a board tunnel, and this is a finished tunnel which is there. And the next size was bigger, so that size we tried to keep the bigger one. So this was the other section which can be seen from the board tunnel, and these are the rock conditions which we are getting in the excavations during the this one. And even soft ground conditions also we experienced during the excavations. Yeah, and this was one of the mucking process which is been taking in the NATM process. And even there was a seepage also been there, and this water was being channelized and pumped to the surface. Yeah. So this was the almost in the finishing stage where the secondary lining process was going on. And this is how the finished tunnel was almost looking like. And you can see a weave with the from the one tunnel to the other tunnel, how this crossing is being taking place from here. So this is how the finished tunnel was there, and this was the conceptual view which we planned for in the 3D BIM model, and this is how the model was. This is how the site was achieved. So we were in successful in achieving this complete uh, conceptual view which we planned at site. Yeah, that's it for today, and thank you everyone. Thank you IIT Jammu for invite.
Thank you, Mr. Muniyappa. Once again, we extend our sincerest gratitude for illuminating us with your expertise on the topic. Your profound insights have deepened our understanding of NATM. I also express my gratitude towards our esteemed faculty member, Dr. Shiva Kumar, for their unwavering support towards academic excellence. And at last, I thank all the participants who made this session possible. And if anyone has any questions, I would like everyone to ask any doubts.
Good morning, sir.
Yeah, Gurman.
Actually, you earlier discussed like uh, we go for during the design of support systems, we do keep in mind like settlement issues and fulfill excavation whether to go for that, and usually some special conditions like squeezing type of condition or so.
Correct,
So,
correct.
what are the actual measures you take during that squeezing type of condition? Is it like only the thickness of that short grit or steel ribs being converted to lattice girders or something? Is it only that, or we need to incorporate some different measures in our design?
Yeah, see, there are two things. One is about the primary support, like where we take the steel ribs into support, and like the yeah, and even the lining thickness of the primary support which we are planning. So in these conditions, the ground may be moving. So based with that, we will have to try to check with the seismic conditions also where this moment are there, and the final lining also need to be planned accordingly with that. So with that, there are several checks also we need to see with the dynamic model also whether these conditions are workable or not. So rarely in one of the Himalayan projects we use these squeezing ground conditions, but in other areas we don't find much in India. Yeah, it's about the support we play, but definitely the surface conditions, because here we have a cover of more than 1 kilometer of rock mass there, but in urban areas we have very crucial covers where we plan to go with one diameter of the tunnel which is 6 meters or 7 meters, and there are a lot of buildings over above, and these settlements are one of the major constraints, so that need to be tackled with an additional support there.
Okay, thank you, Shreyas. I got my answer. So
Yeah.
one more question also, like, is there a distinguish means feature between floor cooling and pipe roofing, or what we call umbrella roofing sometimes? So is there,
Correct, correct.
are they all same, means they are being grouted, or is it
Yeah.
something different?
Yes, yes. See, four pole we call it like a normal rebar with a grouting, because it's generally used for a small grade four kind of rock conditions. But whereas this five proof everything comes in picture where very poor rock mass is there, and entire this umbrella grouting we call it as pipe proof. It's same. So both wordings are same. These will be done because when we have a low cover conditions where we have minimal covers, we need to give an additional support in between the tunnel and the surface. In that, instead of going for an horizontal grouting or other key aspects, we go for a pipe roof which to stable the arching effect. So that we need to try to consider.
Thank you, sir.
Thank you.
So one more thing was there, like we have got primary support and secondary support. In between, we do ensure that we put the membrane for
Correct.
waterproofing or water drainage. So
Yes.
how we achieve that means connection between the primary and secondary? Means how we ensure that, because we are totally putting a membrane in between and we are not sure whether they would be, because it's one of the
Correct.
primary aspects to stitch
Correct.
those
See, the
ground.
primary support, the aim of primary support is to stabilize the ground during the excavation. It's only for the construction stage. Whereas the permanent support, which is the permanent lining, is planned, and all the checks will also be performed in the permanent lining with the same similar ground conditions, similar stress conditions, which is uh, like outside of the lining. So even if the primary support goes as the years goes, but we won't check the primary support for a durability because that is kept for the temporary aspect, and this permanent lining will be kept for the durability aspect where we go for more than 100 years kind of thing. So
Okay, so you mean like it's not necessary and that
it is
we
not
must.
necessary to keep a bonding, but yeah, it's only for the construction stage we keep a robust support system in the primary support till the for permanent lining in place.
Okay, thank you, sir. So one more thing, this is the last thing. Like you in Mumbai Metro, that Sahar station you talked about.
Correct,
Like
correct.
you told, like we usually went for that NATM in between, and
Yes,
it was like we were like you changed the sections there and the section dimensions were changed. So was there
correct.
a particular reason to change the sections? Because it's very difficult to have a design for each section and
Yeah, definitely. See,
completely
what
change
is
the design.
happening, like this is the scissor crossing, and the train has to move from one tunnel to other tunnel in case of any fire incidents or anything emergency. So you need to have a subsequent clearances like a kinematic envelope which need to be planned. All the services which are running in the tunnel also to accommodate within this tunnel. So once you are in a taper conditions, you are approaching the, because I cannot follow the same shape in the taper, and excavation is very difficult. So to keep that clearances, we created a block of natums with a different shapes and different intervals. So that's how this thinking was planned accordingly.
Thanks a lot.
Thank you.
Here's one question from the comments. Upendra is asking, can you elaborate more on stress relaxation in construction stages, and which softwares you use for modeling tunnel?
See, stress relaxation based on the ground conditions again, because if you are in a rock, you may not be necessary to do this relaxation, but in a soil kind of conditions where this mixed ground is there, it is necessary to reduce the relaxing the ground to get some 80% relaxation. We generally go for it, and we use the RS2 or Plaxis also you can use, but we generally use RS2 right now in our modelings.
Okay, if anyone wants to ask any questions, uh, please go ahead. Okay, I have one doubt, sir.
Yeah.
Do you give any consideration to earthquake loading in tunnels, especially in the Himalayan regions? Because
Yes, yes, yes. It is, see, there are, for the TBM tunnels, there is a different kind of aspects which we consider. For NATAM, there is a different aspects. Ultimately, all these considerations need to be taken place in the design of the final line. So there are checks, and nowadays there is a 3D models which can generate the dynamic things. But earlier, there are empirical papers are there by Hashash, or there is a Hashash called paper. We generally go follow that paper for the TBM board tunnels, and for Northern conventional tunneling also we do these checks for the seismic. Definitely, it is required. In all the reports and all the projects, we check this earthquake consideration based on the area zones we take into account.
and what about the interlocking? For example, how do we design the interlocking of those sections? Because
Yeah,
I
see,
was
that's out. Again, we similarly there is a SWEDs and unweds softwares are there. What we do is that we try to because based on the investigation we will have certain assumptions and we checks. But once the face mapping data comes, we will see the blocking, like how much the wedge formation is there, and what is the requirement of the support, like what is the length of the bolting which is required to be supported for this, and what is the overburden which is at the top and which is creating a stress there. So with that, we'll try to plan this additional support.
okay. I think
Hello.
there.
Hello. Good
Yeah,
morning, sir.
yeah. Good morning.
Sir, my question to you is if we are pursuing tunnel engineering and all most of the students over here is pursuing tunnel engineering, so what is the scope of having if we are not moving ahead with the research work and if we want to work in the field? So, what is the scope in India basically of tunnel engineering?
Yeah, that's what I was stating in the initial slide itself, that there are a lot of projects which are upcoming, and government is spending a lot of money in the underground networking, and especially 30% of this tunneling activity is going in Himalayas right now, and the rest of the things are going in urban areas. So all the major cities having a connectivity to the urban tunneling, and we have very less tunnel engineers in India specifically because the people from the different experiences coming and they start gaining the experience here, but still there are not skillful people who can work on the site with the tunneling engineering background or with the rock mechanics or geotechnical background at site level. So there are a lot of requirement is there, but yeah, again, it's about the construction industry which they spoiled the employee roles, because they just take with respect to the their role requirement. But the definitely there is a technical able people are required right now in the market, and there is a huge market in India, and there are a lot of investments are going to come in future for the underground network. In fact, in Bangalore itself, we are right now planning for around 30 to 40,000 crores of tunnel, which is being planned for 18-kilometer length with a 15-meter dia. So there's a very good market now.
All right, sir. Thank you.
Thank you.
There's one more question. Nasir is asking how to choose the cross section for a particular tunnel, considering traffic passage. Will it be single or twin tube?
See, it's depends on the requirement of the client. Like what is the requirement from the client, whether you need to, whether you are doing for a road project or whether you are doing for a railway project, whether you are doing for a metro project. So there are different kind of conditions and different space requirements are there. So like for a TBM, there is a different requirement. For NATM, we need to check with that requirement and need to see that what is the width and height requirement need to be there. And basically with that, we will try to plan with the ground condition, whether we need to go with an elliptical or whether we need to go with a D shape. So that type we will decide based on the ground conditions.
I think we don't have any more questions. So we'll wrap up today's session. Thanks a lot again. And at last, I would request everyone to turn on their camera so that we can take a screenshot. So if you could stop sharing your screen and
Yeah, sure,
we'll take
definitely.
that screenshot. Okay. So yeah, thanks a lot again. We hope that we would have more such sessions in the future, and we look forward to having GeoConsult present in the campus for our placement drive, hopefully.
Sure,
And
we'll try.
thanks a lot. Thanks a lot.
Thank you.
Thank you, brother. Thank you for
Yeah,
giving
thank you,
this
sure.
chance.
Thank you, thank you,
Yeah.
thank you very
We will
much.
meet again, and I hope that if in future, if we are conducting workshop also, in
Sure,
detail, I
sure.
think we can have a
Yeah, yeah,
discussion.
definitely, definitely.
Mostly we require that practical perspective. So,
Okay, that's
so
true.
students are
Yeah, yeah,
having the theory.
we'll plan one day. They
Yeah,
will plan
sure.
it. Yeah.
Thank you, thank you.
Yeah, thank you, sure.